Hello, scientists, and welcome to another session of Ms. Sessa's virtual classroom. So, again, we're going to go over a few things that we didn't get to in class today. So you're going to be taking some notes. I'm going to be asking you to pause the video at various times to make sure that you get things in your notebook. Remember, all of these slides could be on a notebook quiz, so you want to make sure you get these notes in your notebook. So the first thing I want you to do is to have a new page in your notebook and put parts of the atom. You can title that at the top and then put parts of the atom in your table of contents, whatever page number you're at. And you're going to copy down this table here. Okay? So you have 4 columns. The first one says subatomic particle, location, charge, and mass. So I want you to copy this down and then fill it out. So I've given you the subatomic particle here called a proton. You're going to tell me where in the atom you find a proton, what its charge is, and what its mass is. Here I've given you the charge is -1. You're going to tell me what subatomic particle it is, where you find that in an atom, and what is its mass. And then the last subatomic particle, which weighs 1 AMU, what is its charge, what is its location in the atom. So please pause this video so that you can copy this down and fill it out in your notebook, and then we will continue on. Okay, hopefully you've done that. The next thing we're going to do is talk about this question, how small is an atom? So we know it's pretty small, but we haven't really talked about what atoms look like, the size of it. So what I'd like you to do is to click this link here, and it goes to a video, and watch the video on your own time. If I click it here, it's going to sound kind of weird on this screencast, so please do this yourself. And then write down in your notebook what you found. So how small is an atom, and what do atoms look like? Okay, so again, pause the video. I'll be here waiting when you return. Okay, so the next thing that I wanted to talk about is the atomic mass. So we had a question about this today in class. Why isn't the atomic mass a whole number? Can we have half a proton or half a neutron? Well, no, we can't actually. So at least not in terms of protons and neutrons. So why isn't the atomic mass a whole number? Well, we have a thing called an isotope. And again, I'd like you to pause this video and write down just sort of this one at the bottom. That's all you need to write down. And then I'm going to talk about it. Okay, so pause the video, write down the bolded at the bottom, and I'll see you when you return. Okay, so isotopes are elements with a different number of neutrons and therefore a different mass. So elements can actually have varying amounts of neutrons, and some of these neutron amounts are more common than the others. So on the periodic table, those elements that have more common neutron amounts are weighted more heavily than those with uncommon neutron amounts. So if 90% of a carbon atom has 12 neutrons, that's going to be weighted more heavily than a carbon atom with 13 neutrons or a carbon atom with 14 neutrons. So your average on the periodic table is going to look more like carbon 12. You don't need to really worry about that. That's sort of just an aside. What you need to know is that there are isotopes of different elements. So there are elements with different numbers of neutrons. So for example, like I said, carbon-14 is an isotope. Carbon-14 is really important, and we'll learn about this more next year, specifically in calculating how old fossils are. So I have 3 pictures down at the bottom. We have carbon-12, carbon-13, and carbon-14. And those stand for the masses of carbon, right? Carbon-12, carbon-13, and carbon-14 are all isotopes because they have different neutron amounts. So what I want you to do is just calculate how many neutrons carbon-14 has. So you'll have to look on the periodic table and find the atomic number for carbon, right? And then do your calculations yourself. You could also take a look at the pictures down below and sort of try and figure it out that way. That's fine with me as well. But please try to do this in your notebooks. Okay, moving on. What about elements with charges? So how might we get an element with a charge? Really think about it. What do you know about atoms? What do you know about elements? And what do you know about charges within an atom? How could we get an element that's either positively charged or negatively charged? So pause the video and write down your guess. How might we get an element with a charge? Okay, so hopefully you took a guess, you made your hypothesis, and hopefully you said something about electrons, right? Electrons are negatively charged. So if we take away an electron or add an electron, we're going to get a positive and negative charge. You might have said something about adding protons or taking away protons, because protons are positively charged. Well, remember, if we change the protons, we get a different element. So when we're talking about elements with charges, we're specifically talking about electrons. Okay? So what I would like you to write down is pretty much this entire slide here. So pause the video and then I'll explain what we're talking about. Okay, hopefully you finished copying that down. So ions have different numbers of electrons than protons. This means that our positive and negative charges do not cancel out. And we get a charged atom called an ion. So usually we have even number of protons. We have as electrons as well. So if we have 6 protons, we also have 6 electrons. But if we have 7 electrons, right, we have 1 more negative than positive. So we're going to have a negatively charged atom. And negatively charged atoms are called anions. Positively charged ions are called cations. Now remember this because this T in the center here sort of looks like a plus sign. So that's how I remember positively charged ions are called cations, negatively charged ions are called anions. And again, the prefix AN here, I know it's sort of covered up by that slide, means not. So you can kind of think of it as like a not ion, negatively charged ion, whatever you'd like to do. So what I would like you to do right now, I've given you the nitrogen tile right here. So an element with an atomic number of 7, but a +1 charge. I want you to calculate the number of protons, neutrons, and electrons. Okay, so you're going to have to do the same thing with protons and neutrons, but now we have a +1 charge. So something else is happening here with the electrons. And now the same thing, but the opposite. An element with an atomic number of 7, so still nitrogen, but a -1 charge. So what's going on with the electrons here? So pause the video right now and do this out in your notebook. I'm going to go over this in class, so I'm not going to tell you the answer right now. Okay, so just so that we're all on the same page, we have 2 new vocabulary terms. So isotopes are elements with a different number of neutrons and therefore a different mass. And ions are elements with a charge, right? So they have different number of electrons. And I can write that in too so that we understand. Ions with a charge, so different number of electrons than protons. Okay, so if you need that, pause it here so that you can copy that down as well. And then you have 2 homework assignments. So many people said they've already completed part B of the calculating protons, neutrons, and electrons practice problems. If you haven't, please finish those up. You can check Part A and redo your work if you need to. You'll be turning those in on Thursday. And then there is one video on Canvas called Solving the Puzzle of the Periodic Table. It's a 3-minute video. I think there are 6 questions about the video. So please take a look at that, and you're going to submit that one directly to Canvas. The calculating protons, neutrons, and electrons practice problems you're going to turn in to me on Thursday. As always, if you have questions, please email me or come to office hours on Thursday. Otherwise, I'll see you guys then. Thanks.